Thank you. Good morning to everyone, and thank you very much for the invitation to this webinar. And the title of my relation is a paradigmatic autistic phenotype associated with the loss of PCDH11Y and NLGN4Y genes. The next, please. Precedent. Most studies relative to Y chromosome abnormalities are focused on the sexual developmental disorders. Recently, a few studies suggest that some genes located on Y chromosome may be related to different developmental disorders. Mixed gonadal dysgenesis 45X and 46XY is a rare development sex disorder resulting from Y chromosome mosaicism, which induced abnormal gonadal development characterized by a variable phenotype ranging from partial virilization and ambiguous genitalia to freely male or female phenotypes. Next one. The main expression, no. Oh, the third. In recent times, the role played by the Y chromosome in sexual development has been recognized in brain development too. The two XY homologous gene pair PCDH11XY and NLGN4XY are emerging as two important families of genes, protocaderins and neuroligins, involved in neurodevelopmental disorders such as schizophrenia, autism, intellectual disability, and epilepsy, although the clinical evidence is still rare. Both genes code for two distinct synaptic cell adhesion molecules that connect pre- and postsynaptic sites through homo or heterophilic interactions of their extracellular domains, mediate transsynaptic signaling cascades, and regulate multiple aspects of synapse development, function, and plasticity that are essential for the neurotransmission. The main expression of both genes, PCDH11Y and NLGN4Y in the brain and in the early stage of the development, suggest a link with the neurodevelopmental disorders that are more frequent in boys. The next one, please. As the clinical studies of the Y chromosome rearrangements are mainly directed towards the sexual development, here we present a child with mixed gonadal dysgenesis and a severe phenotype with developmental delay, language impairment, and autism spectrum disorder, recalling a regressive subtype associated with a mosaicism, 45X11 and 46XY89 and partial deletion of the short and long arm of the Y chromosome. The next, please. Our experience, the proband, a 30-month-old child, in the only child born to Italian unrelated parents. He was born at 40 weeks of gestation by normal vaginal delivery, following a pregnancy complicated at 7 months by 2 bleeding events. On neuropsychiatric examination, the patient revealed hypotonia and dysmorphic features, including frontal bossing, triangular faces, large penis, right cryptochrysism, and hypospadias. Abdominal ultrasound detected in the pelvic cavity hypoechogenic areas of elongated shape consisted with a persistent Mullerian duct. At 11 months, the child was alerted to his environment, interacted with the examiner, and her mother through a contact and vocalization. He turned his head to sound, vocalized undifferentiated nasal sound and 2 different vowel sounds. He smiled when the examiner smiled and vocalized when the examiner spoke. A formal development assessment by the Bailey scale of the infant and toddler development 3rd edition showed performance in the average range at the cognitive scale. The next one, please. At 25 months of age, the child showed an erratic response to name and did not react to sudden loud noises. He showed inconsistent eye contact and displayed negative affect in response to either the test material and the examiner or caregiver. He avoided all physical contact, did not attempt to engage in social interaction, rarely vocalized the nasal and vowel sounds, but without intentional communications. He showed stereotyped fingertip movements, rubbing, repeated object manipulation, stack of blocks, and a tendency to focus attention on stimuli for too long. His performance on the Bailey Free was deteriorated. The next one, please. At 29 months, a semi-structured standardized assessment of communication and social interaction showed the score of 21 and indicated a moderate to severe level of risk for ASD. As a karyotype 45X and 46XY. He showed a clinical feature fulfilling the criteria of the ASD, identified as a congenital condition in which the development of chromosomal gonadal or anatomical sex is atypical. The next one, please. In addition, it displays a severe phenotype characterized by language disorder, global developmental delay, poor social interaction, restricted interest, and repetitive and stereotyped behaviors with a peculiar clinical course that in some ways could evoke ASD, a subtype with regression of the main developmental function. And the next one, please. Most clinical studies regarding the 45X and 46XY disorders focused on the sexual development aspect. Recently, there is a growing evidence that some genes located on the Y chromosome are responsible for some neurodevelopmental disorders in addition to well-known DSD. Next one, please. We think that within the set of lacking genes, the PCDH11Y and NLGN4Y, despite the incomplete knowledge of their molecular mechanism, can play a significant role in the mental dysfunction of our patient. The next one, please. Proto-cadherins are cell adhesion molecules belonging to the cadherin superfamily. Two types of PCDH11 were identified whose genes are located at XQ21.3 and at YP11.2 and share 98.1% nucleotide and 98.3% amino acid. The next one, please. PCDH11XY mRNA is expressed in many regions of the fetal and adult human brain, including frontal, temporal, and occipital cortex, corpus callosum, amygdala, hippocampus, caudate nucleus, thalamus, substantia nigra, and cerebellum. The next one, please. In addition, a longitudinal study of the prefrontal cortex using microarrays showed that levels of PCDH11Y change at different age, being highest in male neonates and decrease through infants and childhood. The primary expression of PCDH11XY in the brain suggested their significant role in the development and the functioning of the brain, although many of their detailed molecular mechanisms are still unclear. Virapa A.M. Tail in 2013 reported genetic analysis of 14 developmental dyslexic patients, disclosing that 5 individuals as duplication ranging 113 and 166 kilobyte, and one patient the deletion of 2 megabyte at XQ21.3, including PCDH11 gene. The next one, please. Spivak Tail in 2011 reported a male child with a severe language delay associated with a small deletion within the PCDH11XY gene. The X chromosome deletion was inherited from the unaffected carrier mother, but the Y chromosome deletion was de novo occurrence. The next one, please. This time suggested that the PCDH11XY genes in humans play a role in language development, and that rare copy number variation is a possible mechanism for communication disorders. Intriguingly, the deletion of Y chromosome of every patient extended to YQ11.23 region and includes the NLGN4Y, a family component of the 5 phosphonactic cell adhesion molecules NL1, NL2, NL3, NL4, and NL4Y, that interacting with the presynaptic neurexins maintain transsynaptic connection and function. The next, please. NLGN4 and NLGN4Y transcripts were detected in all male brain regions without significant difference in regional distribution syndrome. It has been reported that mice the neurolesion-4 mRNA levels increase from embryonic to postnatal phase with a plateau at 3 weeks. The next one, please. Functional analysis showed that the loss of neurolesion-4 caused a profound and selective reduction in glycinergic synaptic transmission, interacting with the inhibitory postsynaptic Jeffrin and the colistin proteins without impairing excitatory synaptic transmission. The next one, please. A clinical screening for mutation in NLGN4 in autistic individuals identify a frameshift NLGN4X mutation, producing a stop codon at position 3, 9, 6, and 2 brothers of the Swedish family, one with the typical autism and the other with the Asperger syndrome. The next one, please. Later, 2 BP deletion in NLGN4X, leading to a premature stop codon encoding a truncating NLGN4X protein, was detected in 13 males from a French family with intellectual disability, including 2 males with autism and 1 with pervasive developmental disorder. The next one, please. Interestingly, NLGN4Y missense variant without the variant in the homologous NLGN4X gene was found in a patient with autism and in his father with learning disability. The next one, please. Sadly, other studies did not disclose a rate of NLGN4 mutations in autistic patients, and it is likely that NLGN4 mutations may be responsible for a small subset of patients with autism, perhaps associated with a wider spectrum of neurodevelopmental disorders with mild to severe cognitive deficit. The next one, please. The comparison of results of above mentioned studies suggests that the mutation of both PCDH11Y and NLGN4Y genes may be consistent with the temporal patterns of onset and the clinical feature of our patient. Indeed, our subjects revealed an early and persistent pattern of language development suggesting a detrimental influence of PCDH11Y on the basic processing underlying the language maturation as above mentioned. The next one, please. In addition, previous studies documented that the most inhibitory neurotransmission mediated by GABAergic and glycinergic synapses during the first 2-3 weeks of rodent postnatal development shifts from a mature depolarizing to mature hyperpolarizing functioning, and from GABAergic to glycinergic transmission. The next one, please. This temporal pattern to late maturation of glycinergic neurotransmission seems to agree with the late appearance of autistic symptoms in our patients, suggesting a possible relation between the lack of glycinergic inhibition and NLGN4 modulated and the onset of the autistic behavior. On the next one, please. On the other hand, it has been reported that about 1/3 of ASD patients experience a developmental regression between 15 and 24 months, whose causal mechanism remains elusive, thought a genetic contribution, including genes coming from a postsynaptic density protein, is recently emerging with the strand. In conclusion, our data, the next please. Our data consciously suggests that both genes may play a complementary functional role in the development of our patient disorder. Thank you for attention. If there are the question, I prefer send mail because